Okay, so again, in these lectures, we're going to discuss about loops. And as we said earlier, again, in Python, the two major loops are the for loop and also while loop. So our main objective is to go through the while loop first. Then later on, we shall cover the for loops. So this is the motivation, the question given to us here. So for example, if I want to write a program and the program is going to print programming is fun, or it's going to do something over and over again. Well, I don't want to write the same code. In this case, I'm printing programming is fun 100 times. I don't want to write a print statement 100 times. Or for example, I want to find the sum of numbers from 1 to 50. Well, I don't want to write 1 plus 2 plus 3 plus 4 up to 50. That's too long. So this is where a loop will do a lot of work for us. So that's the question. How do you solve this problem? If I want to write print programming is fun, I want to print programming is fun 100 times. Again, suppose that you need to print a string, programming is fun 100 times. It will be tedious again to have to write the following statement 100 times. It's too much. So this is where the loop will come. So this is the example of solving this problem. Here we are writing print, programming is fun 100 times. I mean, that's time consuming. And also it will make the program very, very large. So the best way to solve this problem, as we said, our main objective first here is to go through, let's close this. So it's to go through the while loop first. So this is what I will write. Instead of writing programming is fun 100 times, I'm going to use a while loop. Now, anytime we are using a loop, we always have to have a variable that will keep our counting for us, or we normally call the counter variable or something. So for example, I start my variable name count from 0. Now in Python, the keyword while is for, again, looping. Everything is lowercase while. So maybe I can declare an identifier, let's say a variable. I may name it while, but I'll start with, or I may have any uppercase, or I may start with W, that's fine. But Python understand while means something else for us. In this case, it's a loop. So here we say while the count is less than 100, we want to print programming is fun. Now we need to increment the count, because if we don't increment the count, we are going to have something we call the infinity loop. Because first of all, the count is 0. So we check our condition. Is 0 less than 100? Yes. If 0 is less than 100, anytime the condition is true, then we are going to execute the statement below. And again, just to remind us, we can see we are using some indentation since the while is not the same align with print. It means print is inside the while condition. So this will print first time, then we increment the count. 0 plus 1 will be 1. We check is 1 less than 100. Yes, we print the program is fun again. We increment to 2. Is 2 less than 100? We keep going until we reach, let's say 99 is less than 100. By then we are going to print our last statement, programming is fun, which is from 0 to 99 means we have printed it 100 times. Now 99 plus 1 is 100. Is 100 less than 100? No. So now the loop will terminate. It won't do anything no more. Also, if we like, we can start the count from 1. So I'll say the count equal to 1. Then the condition should be count is less than or equal to 100, so that we can go from 1 to 100, which is also, again, 100 statements. The program is fun 100 times we're going to print. So I'm going to wait for a few seconds if this is okay. So again, our main objective is to learn how to write programs using the while loop. And also we are going to develop loops following the loop design strategy. So we can see the while loop, we need a strategy is that we need some variable to keep our count, and we need to initialize it. The initialization value tells us where we are starting from. Then we need to have some condition. That condition must be false, at least after some time. If the condition cannot be false, that means this loop will execute forever. It can't stop. Then the only way we can, in our case, the only way we can, the example we saw, the only way we can, again, and let's go back, the only way we can have this condition to be false, then maybe we need to increment our count. Now, if we decrement our count, the condition will never be false, because the value, if we are decrement count from 0, we go to -1, -2, etc., which means it will always be, count will always be less than 100. So those are, again, we shall go through the step-by-step strategy. And also sometimes we may use a Sentinel value to control our loop. So for example, let's go back here. In this program here, we know we are, again, 100 times. We are 100% sure because we start from 0 to 99. Now, sometimes we may have a Sentinel value. In terms of Sentinel value, I don't need to initialize the count no more. And also I don't need increment or decrement the counter. Basically, I can say, okay, y count is not equal to, you can choose any value as a Sentinel value. A Sentinel value will be the value that would determine whether the loop should terminate or not. So if I say y count not equal to 50, print programming is fun. We are going to remove the increment. We're also going to remove the initial statement here that count equal to 0. So we say y count not equal to 50, program is fun. So if the user enter 50, what will happen? Who can tell us? We don't have the count we didn't initialize it no more. And also we don't have to increment or decrement no more, but we are using what we call the Sentinel value. So we say y count not equal to 50. We want to print programming is fun, which means if the user enter any value, we are going to print programming is fun because it will be true. We have a statement not equal to 50. So if the user enter 20, is 20 not equal to 50? Yes, it's true. So we're going to print programming is fun. Anytime the user enter the exact Sentinel value, then the loop will terminate. And the reason why we use the Sentinel value means we don't know how many times the loop will execute. So the first time, if I say y count not equal to 50, if I enter 50 for the first time, that means the loop will not execute at all. It will terminate for the first time. So that's why, again, we will see example. So that's one of our objectives, how to control a loop with a Sentinel value. Then also we're going to see some few programming examples. Here, for example, we say to obtain a large amount of input from a file by using input redirection instead of typing from the keyboard. There's a program example we're going to see how to use. So let's start with the basic concept again with the while loop. This is again the flow chart. So here we say while, again, the keyword, this is a reserved word or a keyword in Python. It means a loop. So we say while the loop condition, if it's true, then we're going to do something which will be our loop body. In the loop body, of course, we may have maybe one or more statements to execute. So the example is on our right side again. Here we are not using a Sentinel value. So since we are not using a Sentinel value, we need to initialize our variable that will keep track of how many times the loop will execute. So here we initialize it to 0. Again, in Python, I won't use the term declare variable. If it's, again, it's a Java class or something, we may say we are going to declare and initialize the variable. So here, basically, just initialize it. The initialize can be any value. So if I initial count to 5, it means I start from 5, which is fine. Then I'll say count is less than or equal to, if it's 5, I'll say 105. So if I start from 5 and I end at 105, I still print 100 times. So it's up to you. So again, that's the same example here. So we look at the flow chart, we initialize our count to 0. So the first thing we check is 0 less than 100. Yes, if it's true, then print programming is fun. Then we increment the count to 1. We go back again, check the condition. It's 1 less than 100. Yes, then we print programming is fun again. Then we keep going. Now let's say we reach 100. Is 100 less than 100? No, then that's false. So we come out of the while loop. Maybe we may have some more statement to execute, but first thing, we come out of the while loop and we continue executing our statements. Okay, so if no question, let's see the tracing the steps here. So for example, here we want to print programming is found only 2 times and we don't have time for 100, so 2 times. So first we initialize our count again to 0. Then we check, is 0 less than 2? Yes, it's true. So if it's true, we are going to print, and here we are using, well, there's a mistake here, it's supposed to be programming is fun. Here we say welcome to Python. So it depends what string we have here. So we're normally going to print programming is fun. Then what we do, we increment the count by 1. Now let's check again. Is 1 less than 2? Yes, we say it's true. Okay, then we print again, programming is fun. Then we increment our counter to 2. Now is 2 less than 2? No, we say it's false. Now, since it's false, we cannot print no more. So we come out of the, again, the while loop. And if there's any statement to execute, we execute it. I'll wait for a few seconds if any question. Okay. So let's see one program example here. Again, this program we said is an advanced math learning tool. And if we are using this textbook in chapter 4, there was a program on this, but again, they didn't use a loop. They just used only selection statement, which means if it's a quiz, one question after I answer it, I'm finished. But now if we use a loop, maybe we may have a condition that if the answer is wrong, try it again. Or we may have a condition that, okay, the first quiz is over, go to the second one. So let's see how this program works. Here we say it gives the program that prompts the user to enter an answer for a question on subtraction. So we have a subtraction question, maybe 7 minus 5, whatever the answer is. Now using a loop, we say you can now rewrite the program to let the user enter a new answer until it's correct. So the previous program, we only use selection statement. If your answer is wrong, it's wrong. You don't have no second option. We can make it, but that means we have to write the code over and over. As we saw the first example, if I want to print 100 values, then I have to write print statement 100 times. But with loop, I may write a statement only once and I'll put it inside the loop and it will work. So let's see this program. Hopefully we can see it. Skip. Let me see if it will work. Okay, it works. So this is the program here. Now, the reason why I think we used the random package before, or I'll say the class before, which can, again, we can generate any random numbers. So we import a random, and we want to generate 2 random single digits. So we say from 0 to 9. And we are using the runInt method to generate. RunInt will generate an integer values for us. So this will be a whole numbers. So we are generating any number between, again, what is given here, any single digit. So next thing we do here, we say that, okay, if the number 1 is less than number 2, we want to swap number 1 with number 2. So again, this is one of the good example in Python. Now, if you have taken a Java or other programming language, if we are swapping two numbers, we need to declare a third variable. Then we put the first value or the second value in the third variable. Then we assign the first or second value to either the first. So let's say we have num1 and num2. I will declare third variable named temp. I will give num1 to temp. Then I'm going to assign num2 to num1. Then I'll assign the temp to num2. So this is how we do it always in any programming language when you are swapping values. But Python gives us a very easy way to swap values. So you can see here, we say that if num1 is less than num2, we just have to change it. Use the assignment operator and change the position. So we have num1, comma, num2 equal to num2, comma, num1. So now we are assigning num2 to num1, and we are assigning num1 to num2. Now, the reason why we have this condition is that we want to get a positive result. So if I enter 7 as the first value, and I enter 8 as a second value, well, 7 minus 8 will give me -1. But we want positive answer. So if the second value or the first value is less than the second value, or the second value is greater than the first value, we want to swap it so that when we find the difference of num1 minus num2, we get positive result. So next, we prompt the user again to give us the answer. So first we generate two random values. We make sure that the numbers, the first one should be greater than the second one, and we swap it in case. So in this condition, if the first value is, let's say 5, and the second value is 3, then this condition will be false because 5 is not less than 3. Then we skip the if statement. Now we come here to ask the user to enter the correct answer, which is num1 minus num2. So here we use the input function to get a result from the user. So we ask the user, we ask the user a question: what is num1 minus num2? And the question mark is there. So user will enter the answer into the variable name answer. Now we are using the while. This is what we are learning. This is what we are learning today. We are using the while loop so that we can, if the user get the answer wrong, we can keep asking the user to enter the correct answer. So now our condition for the while loop here is kind of like a sentinel value, because we don't know how many times this loop will execute. For example, if the user entered the answer correct for the first time, then this loop will not execute. So sentinel value here means our condition is that if the num1 minus num2 is not equal to the answer the user entered, which means the answer is wrong. So we use an input statement telling the user to try it again. So the user will come and enter the correct answer. If the user entered the correct answer, then we are going to, we are going to skip the loop. And then we print that the user got it right. And you can see the indentation. So the print, you got it, will be only printed if the while loop condition here is false, which means if num1 minus num2 is the same as the answer the user entered, then we are not going to ask the user to enter it. The user entered the correct answer, so we're going to skip everything, just print you got it. I'm going to wait for a few seconds. Again, the main thing I want us to understand is this section. That's our main objective in these lectures. Again, the selection statement, we did it in our previous chapter. The only thing, again, if you have taken, the reason why I mentioned this, if you have taken Java or C++, if you want to swap a value, you need a third variable. So you put the first value in the third variable, give the second value to the first variable, then take that value from the temp, assign it to the second variable, then you swap it. But Python gives us a nice way that we can use the assignment operator to swipe. Okay, so if no question, let's keep going. Let's see. Let's my slide. Let's escape. Normally, escape should. Oh, okay. So let's keep going. We also have another example here. In this program, we are going to guess numbers. So here they say we should write a program that randomly will generate an integer between 0 and 100 inclusive, which means including 100. Now, the program will prompt the user to enter a number continuously until the number matches the random generated number. So this means we ask the user, first of all, we have to generate the random value. Then we ask the user to enter a number if the number is the same as the number that was generated randomly. If it's not, then we should have a loop. So here also we have to use the concept of Sentinel value. That means if the random number generated is not equal to the input that the user entered, then the user have to keep trying. Sometimes we can give the user, which is saying here, if we saw that the input that the user enter is too large, we will tell him that your value is too large than the random number generated. Other than that, the user will be guessing for a long time. If the value the user enter is too low, we may tell him, no, it's too low, enter a larger value than what you entered there. We keep going. So we have the first one, which is guess number 1 time. Let's see if we can, okay. So you can see here, we don't have no loop. So that's why we can do it only once. And we generate a random value again using the rand int, any number between 0 to 100. Then we tell the user we are going to guess a magic number between 0 and 100. Now we tell the user, enter your guess. We already generated a number already, and we assign it to a variable name number. So the number the user enter goes to a variable name guess. So now we're going to check if the user number that he guessed is equal to the number that was generated. That's great. You got it right. If it's greater, we are going to say the number you guess is too high. Otherwise, we have only 3 options here. If it's not equal and your number is greater, then the last means your number is less than the guess number. Now you can see this is exactly what we did in chapter 3. So the user can only guess once at a time. Now we can check what we can do. Let's see if we can get this again. Let's see the guess number. I think this one, we use a while loop. So it's the same thing, but this time, let me highlight it here. Actually, let's do it up to here. So this time you can see what we are doing here. We are using a Sentinel value. As we said earlier, the Sentinel value can be any value. Here they decided to use -1. Who can tell us the reason why? Somebody to tell us the reason, just to make sure we are all in the class, everybody can hear me. Let's do some few interaction. Why I don't use 50, 60, 70 or any value as a guess value, but I'm using, or we are using -1.
Do you have to use the number as a placeholder? Like, so you can change it or use it in the while function?
Okay, so the main reason will be, we can say the random number that can be generated is between 0 to 100. So if I like, I have to use a number that is not in that range. It's not between 0 to 100 because those numbers can be, it can be guessed because the numbers that the computer can give us or generate randomly is between 0 to 100. So I can use the Sentinel value any negative value will work. I can say negative 99, negative anything. And also if I want to use positive value, then I have to start from 101 or 102. So again, that's the main reason. So here we say, okay, if guess not equal to number, which means what? It's not correct. So enter new guess. So this while loop will stop if the user guess the right number, the number that was generated. So again, the same previous program, but this time the user have to get it right in order to terminate this program, I mean to stop the program in general. So anytime user enter wrong, we are telling him again, guess it again. So you have to keep guessing until you get it right. When he gets it, we check the 3 conditions here. Now we say, okay, the number is correct. Okay, the number is correct. We will go back and check if the number is correct, then the while loop cannot execute no more. Because let's say the number generated was 10 and I was able to guess 10. Okay, is 10 not equal to 10? That's false. So the while loop cannot execute no more. But if we generate any greater value, let's say 20, it will print that 20, your guess is too high because 20 is greater than 10. Then we come here, is 20 not equal to 10? Yeah, that's true. So the while loop will execute again. Wait for a few seconds if it's okay. So next time if we have a Zoom, I'll wait till maybe 10 minutes before the end of the class. I may take attendance. I saw that three students or so have left. It was around 33, including me. Okay, so if no question, let's keep going. Let's minimize this. Okay, so here also we have another example. Again, I'll skip this example for now because of time. We may come back later if we have to. But the same concept, but this time they are using multiple subtraction. So we may have more than one question. Here they say you can use a loop to generate questions repeatedly. So we may have more than one question. So this example here gives a program that will generate 5 questions. So for example, I can have a while loop. Inside the while loop, I can randomly generate 2 numbers to find the difference of them. And in this while loop, I'm going to have a counter because I want to go up to 5. So I will not use a Sentinel value. So I will start the counter from 0 up to 4. So when you do the first question, whether it's wrong or if the question is wrong or correct, I don't care because I want you to answer all the 5 questions. Then later I will tell you which ones you get 2 out of 5 or 3 out of 5. Now, if I want you to answer the first one correct, that means I may have another loop again, condition again, telling me that if you get the first answer wrong, you have to keep trying until you get it correct before you come out of the loop to go to the second question. And we may see examples. So as we saw previously, how to end a loop with a Sentinel value, I think the 2 examples were enough. Here also we can see one more example. Actually, let's go through this example. But here we are saying that often the number of times a loop is executed is not predetermined. So this is the main reason why, again, we are using Sentinel value. If I know the previous example, I know the student is going to answer 5 questions. Well, I know the loop I have to execute 5 times. Or I want to find the sum of numbers from 0 to 100, then the loop have to execute 101 times. But when you don't know how many times the loop will execute, then we can use, this is when we use a Sentinel value. So this is an example here using the Sentinel value again. In this program here, we are going to ask the user to enter a whole number or an integer. Somebody maybe have your mic on. If you are not speaking, you can turn off your mic. Again, make sure you have your mic off, so we don't get the echo. Well, let's see the participants, see if I can. Okay, we have. Okay. So again, this program is the whole idea here. I'm going to highlight again the Sentinel, excuse me, the Sentinel value again. So here we ask the user to enter an input, enter an integer. The input exists if the number is 0. And now here we say keep reading data until the input is 0, which means if user enter a value, we don't care what value you enter, but anytime you enter 0, we are going to stop. Then we are going to sum everything. So for example, if here we start a sum from 0, and then user enter 10. If user enter 10, now we know sum plus equal data means sum equal to sum plus data. So if sum is 0 and the first value the user enter is 10, 10 is not equal to 0. So it will be 10 plus 0. Our new sum will be again 10. Next time the user enter 5. Is 5 not equal to 0? Yes. Then we are going to have 5 to our last sum, which was 10. So it will be 15. Next time the user enter 1. Is 1 not equal to 0? Yes. So 15 plus 1 will be 16. Then next time the user enters 0. Okay. When the user enters 0, we are going to print our last sum we have, which is 16. So we say the sum is 16. So the whole idea here, this is a very simple program, is how to use the Sentinel value. Here, we don't know how many times the loop will execute. So our Sentinel value here is 0. So that's what they said, keep reading data until the input is 0. If input is 0, we cannot read no more data, because in this while loop, we are doing summation of our input that we enter, and at the same time, we are going to execute the input function so the user can enter a new input. So if the while loop terminates, user cannot enter a new input no more, and it only terminates if the user enters 0, because we say the while loop, the condition must be false before the loop will stop. If the condition is true, the loop will keep executing. Wait for a few seconds if it's okay. Okay, so let's keep going then. Now they give us some cautions here. Actually, one of the main cautions is we should be careful with the boundary of the values. The first one I will mention is that if I know I'm going to execute something 100 times, I will start from 0, but I'm not going to end it at 100. I will end it at 99. Or I can start from 1 and I'll end it at 100. Now, most important thing the book mentioned here, which I think is very rare, that you are going to write a loop and you are going to use your counter variable as a decimal values. Because decimal values, you have to be careful how many decimal places you want. We can have 0.1, next can be 0.2, or it can be 0.11. So because of that, they say don't use floating point values for equality checking in the loop control, since floating point values are approximation for some values. Because I may have 0.116. Well, next time, instead of writing 0.116, I'll write 0.12, or somebody may write 0.12 to approximate it, because we don't know. The decimal places can be 10. If I declare variable as a float, the decimal places can be up to 7. If I declare it as a double, the decimal places can be up to 14 or 15. So this is very important. Decimal values, sometimes they will be approximation because of decimal places. So we shouldn't use it. And also sometimes here, for example, we are summing the decimal values. Again, it depends on the decimal places you have. So do not do a decimal arithmetic operations, or even your variables, so shouldn't be a decimal value. It's very rare to even have a decimal value as your counter variable. It won't give you, excuse me, it won't give you the accurate result. So that will be the conclusion for while loop. So next we move to the for loop, if no question.
I have a question.
Yeah, go ahead, please.
So for the first example that we did, for the guessing of the numbers, why was it again that we set guess equal to -1?
Oh, yeah, the reason why you say that we are guessing numbers from 0 to 100. We can say the rand int, the random number, that we use the method rand int, and we say 0 to 100, which means we want to guess any number between 0 to 100. So now if I use a Sentinel value between 0 to 100, I'm going to get a wrong answer, which means, for example, I say, okay, the Sentinel value is 60. Now, if user, we get a random number 60, and now we are checking the Sentinel value is 60, and that will give us a wrong answer. So the best way, always when you have we have a range of values from 0 to 100. So you can use any Sentinel value out of that range. So here we decided to use -1. If you like, you can use positive value, let's say 101 or 102, because we know the program cannot guess 102. It can only guess any number between 0 to 100. So that's why.
Okay, so we're just setting the program up for failure so that it can repeat.
We set it for failure.
When you set it to a wrong value on purpose, right?
Yeah, the Sentinel values always have to be a number. In this case, we want to generate a random value and check if it's correct. So if we are using any Sentinel value, it should be a value out of the range, out of the random numbers that we can generate. I don't know if, so for example, we saw another program that if a user enters 0, we want to stop the program. So that means user can enter any value, but as soon as he enters 0, the program will stop. So Sentinel value will be a number that is not equal to something you want to do.
Okay,
I
I
hope
got
I answered your question. Oh, okay.
Yeah, thank you.
Yeah. So now let's go to the for loop. Again, our textbook, we kind of have the slides all together as one slide, but here again, I break it into 2 so we can separate it. So hopefully after this lecture, I may post these slides also in the classroom if you want to take a look. The good thing about these slides, again, we have a lot of program examples already, so you can take a look at it also. So let's go to the second part, which this will be for loop. So our main objective is how to use a for loop to implement now for loop. The difference between while loop and for loop is that in while loop, I can implement it as a counter control loop. A counter control loop here means we know how many times the loop will execute. Now with while loop, I can use a Sentinel value, which means I don't know how many times the loop will execute. But with for loop, you always have to know how many times the loop will execute. So we only use for loops for counter control loops. Again, counter control loops means we know how many times the loop will execute. Then next also, we're going to see how we can use a nested loop, which means loop inside another loop. And as we said earlier, when the outside loop is false, we can't go inside. We cannot go and check inside loop. So first, the outside loop have to be true in order to go to the inside loop. Now, inside loop will do something. When it becomes false, it will send the control back to the outside loop. And the outside loop will keep doing it. If it's true, it will send back to the inside loop. Inside loop will keep doing its job. When it's finished and it gets false, it will send the control back to outside loop. So the outside loop have to be false in order for us to come out of the nested loop. Again, we may see example about that. And also here, we're going to learn the techniques that we can minimize numerical errors, and we'll see how that works. And also we're going to learn loops. We may see a program called GCD. We may see a program called Future Tuition, and also Monte Carlo simulation, which is a probability concept. We may also see an example for prime numbers. Maybe we may go through a few of them. Again, depends on our time. Seems like we're almost 11 o'clock now. Then we may implement program with break and control. Actually, I will go, break and continue. Actually, I will go straight to this section for the theory. Then hopefully the examples here, we may do the lab work next week Tuesday. So this is how for loop works. For loop is more easier to write. You see here, we write the while loop, it's like 3 lines. You have your counter I variable, we initialize it. Then we check the I condition here, then we do something. After that, we either increment or decrement the I. Then we go back again, check. So it's kind of like, but the good thing with for loop is that everything is in one line. So you can see, I'm writing the same while loop, but here we say for I. In for loop, we are using a function named range. The range will tell us where we start, where we end. So for I in range from, let's say from 0 to 9, the loop is going to execute from 0 to 9 will be 9 times, not 10, 9. So it will execute from 0 to 8. Very simple. So again, use the range function where you want to start, where you want to end, then the loop body, that's it. So we don't need a counter, increment or decrement, and we don't need it here. So let's see an example. First of all, let's understand the concept of range function, how it works. So range, we can have only one argument value. For example, if I say range 2, it means I'll go 0 to 1. If I say range 10, then I'll go from 0 to 9. That's when you have only one value. Let's say range 8. But here, we can also have 2 values. So if I say range 4 to 8, it means I want to go from 4 to 7. And this program is going to print 4, 5, 6, 7. So there's a reason why we start from 4, because we don't want to print 0, 1, 2, 3. But if I want to do something else, I can start, instead of saying, if I want to do something 4 times, I can just write 4 here, then it will go from 0 to 3. So when a range have 2 values, it will tell you the first will be where we are starting from, but the second B to be B minus 1. So if B is 8, we go up to 7, but we start from 4. So here you can see this program is going to print the value of V. So we say for V in range 4 to 8, print V. So we start from 4, which means V equal to 4, so we print 4. Next, we move to 5. We print 5, we move to 6, we print 6, we move to 7, we print 7. And it's 8, so we stop at 7. Now, that's what we said. So if the range is only one value, let's say B, here we say range 4, then we are going to print from 0 to 3. So the range have 3 options. It can have 2 values, 1 value, or 3 values. 3 values will control, for example, if I want to print from 0 to 100, but I want to print 0, 0, 2, 4, 6, 8. I want to print only the even number. Now, if I say 0 to 100, it will go 0 to 99. So I'll say 0 to 100 plus 2, which means it will skip 2 times. When you move from 0, it will go to 2. When you move to 2, it go to 4, because we have the third variable plus. And we call that the step. So range A, B, and step. So for example, we can say this is a very good example, 3, 9, 2. What we print first? 3, of course, we are starting from 3. But 3 plus 2, we move 2 steps, not from 3 to 4, but now it will be 3 to 5. So our second value that will be print will be 5. Then from 5 plus 2 is 7. Okay, 7 can print, so 7 print. Now, when we move from 7, it will be 8, 9. No, we go up to 9, so 9 cannot print. Now, if this is 11, then 9 can print. 8 cannot print because we are moving 2 steps at a time. So if we move from 3, we go 5, 5, we go 7, 7, we go 9, 11, 13, etc. So first, if we understand how to use the range with the arguments, now we can go to a for loop. And that's the example for V in range 3, 9, 2 means we print 3, 5, 7, step 2. And now the same thing, but this time you can see the range is what? Negative value, which means we have to start from bigger value. So it's like we are descending instead of increasing, we are decreasing. So descending order. So I'll start from 5, but I say -1. So -1 means I'll go 5 to 4, 3, 2, 4 to 3 to 2. But because we end at 1, we can't go 1. So we go up to 2. And this means decrement 1. We can also say -2, which means we move from 5, we go to 3. 3 minus 2 give me 1. No, because we have 1, we can't go to 1. Wait for a few seconds if it's okay. Yeah. Well, let's see. I think we have a message here. Let's look. Okay, I'll check that one later if I didn't mark it yet. So we also talk about nested loop. So a nested loop means, again, a loop inside another loop. So let's say this example here. So what we are learning is here right now, we can see the for loops. We have a for loop outside. Then we have for loop inside. So which means if the first for loop execute once, it will do whatever you want to do, which is to print something. Then it will go to the second. Now, when you go to the second loop will do whatever you have to do here, which is another print again. But the second loop have to print everything from 1 to 9 first. So you're going to print from 0 to 9. Then you cannot print 10. So that means it's false. When it's false, it will take the control back to the outside loop. The outside loop did 1 before. So now outside loop is going to do 2. So when it's doing 2, it will go back here again. And here we'll do again from 1 to 9. Then it go back 3. So you can see the outside loop do one at a time, but the inside loop will do everything until it becomes false, then it go back to the outside loop. So this is like, again, coming up with a multiplication table. So first we print the multiplication table string. Then we display some empty spaces. This will be the format. Now we say for J in range 1 to 10, which means we go from 0 to 9. We are going to set empty space formatting and also signal the end. And so what we did here is just the number of columns we may have here to be 10 from 0 to 9. Later we go, actually, let's see if I can do the animation here so we see how the output look like. Let's see if it will work. Yeah, it will work. The only thing, I'll see if I can zoom it bigger. Where's the zoom? The zoom should be this. No. You should have a zoom somewhere. Let's see. This will download it. I thought we should have a zoom somewhere. Okay, this is it. So let's increase the zoom as much as we can. Okay, it should work. So that's the code again. So the first thing, of course, we saw the print. So if we execute the program, the first thing that will print is multiplication table string. Then we click next. So everything here is going to give us, as we said, we are starting from 1 to 10. So which means we go from 1 to 9. So that's what gives us 1, 2, 3 up to 9. Because we can look here very straightforward. For J in range 1, we are going to print a space first, then we print the J value. So that's why we have space, then 1. Then we end it, empty space. The condition is stay true, so we have to go to 2. When we print 2, we print a space. When we print 3, we print a space all the way to 9. When we reach 9, we print 9, the space. Then J will be 9 because J will carry the values. J will be 1, 2, 3 up to 9. But anytime we want to print the value, we print a space. That's why we have spaces between the values, a big space between. Then we have to end it. So everything here, then when we finish, we just print underline the arrow, underline it. So I'll wait for a few seconds if it's okay. Here we are using only one for statement. For J in range 1 to 10, we want to print space. Then we print the value of J. We start from 1. Then we end it with this signal here. Then we go to 2, 3, up to 9. So we go next again, if no question with this output. Okay. So now we say, okay, for I in range 1 to 10, this is our outer loop. So we are starting from 1. So first we print, we get 1, we're going to print I. So we're going to print 1, then we print a vertical line. And we have the end signal as empty here also. So let's click here. So first we say the I value, we're starting from 1. So I will be 1. And that's what we have here. And then when we say I is 1, we print the vertical value. So you can see that when we print the I1 vertical value, we end it. What we have to do, we are in the inner loop. So we have to execute everything here before we go back to the outer again. So inner loop said we have to print J values from 1 to 9 against 10. So it go to, so that's what we have here, 1 to 9 is 10. Again, the first one here is the outer loop. First, we print the outer loop 1, then we print the vertical line, and we end it before we start with J 1 to 10, and that's from 1 to 10 here. Wait for a few seconds. The reason why I want to go through this is that the nested loop sometimes is very tricky. You have to take your time. But if you understand the basic concept here is that if you are in outer loop, you execute only once. If it's true, then you go inside inner loop. Inner loop, you have to execute everything until it becomes false before you can come back to the outer loop. If the outer loop is true again, you have to execute one time. Then you go inner loop, you do everything over again. So you keep doing that until the outer loop is false, then we come out of the loop. So here, let's click next again, see what will happen. You can see when it becomes false after we reach 9, I become 2. So we are starting from 2 again. Then 2 is good. So we are going to do everything in a loop again. So you can see what is giving us. Let's scroll down. That will be the second line. So we see the second line, we have 2 with the vertical line again. Then this time we are going to do what? If you remember, we have multiplication. I is what? 2. I is no more 1. The first one we get 1, 2, 3, 4. Why? Because 1 times 1 is 1 times 2, 2, 2. So it gives us the same thing. Because anything we have outside the I, we are going to multiply it by the inside range from 1 to 9, because 110. So this time we are going to have 2 times 1, 2 times 2. So it's 2, 4, 6, 8, up to 18. We go up to 9. 9 means 18. And we did this already, 4D. So J column 4D, the placement order for the value. So this is how we're going to repeat all over. When we get to 3, let's go next. we are going to multiply 3. 3 is good because it's 1 to 10. We haven't reached 10 yet. So now we are going to multiply 3 from 1 to 9 again. And that's what we have here. So it will be 3, 6, 9, up to 27. 3 times 9 is 27. And I don't want to repeat it because of time. The main thing, if we understand once, that's it. So we can keep doing it. Let me do this quick. You see the conditions, it remain the same until we reach 9. 9 will be good. Let's reach 9 and see. So 9 is okay. 9 times 1 is 9. 9 times 9 is 72, etc. No, we're still in 8. I think I thought, 8. Okay, let's go. This is 8. Let's go to 9. 9 should be okay, which will be the last one. So 9 times 9 should be 81, the highest value here. Now, when we click next, it will tell us that, okay, our condition now is false. And that's what they said. The program is finished. You may restart the animation, because after 9, if it's 1 to 10, then we go off to 1 to 9. Wait for a few seconds if it's okay. Okay, so let's keep going then if no question. So sometimes also here they say we can minimize numerical errors, and this is just advice they are giving us, as we said earlier. When you are using loop, do not use decimal values, whether for addition or counting the variable or the number of loops, etc. Do not use it. So they gave us an example here also, because of, again, decimal values can be approximations. And now due to time, we almost have only 3 minutes left. I'll skip this for now. Again, we're going to do the lab work in class, so we may see more examples. And I'll skip this also for now. I want us to do one more theory, then we finish with this chapter 4. Okay, so here, how do you use break and continue? Now, when you have a loop and you use the statement break, it means you want to stop the loop. You don't want the loop to continue no more. But if you use continue, it means you want to skip some condition. So I may have a program and I may say, okay, I want to, let's say I use a for loop. I want to go from 0 to, let's say 0 to 9. So I have 0 and 10, which means I go 0 to 9. And I'm going to add numbers. Then I may have a if condition that if the counter, let's say the counter variable is v. Now I can say that if v is equal to 5, continue. It means I want to add all the numbers from 0 to 9. I use 0 to 10. So I want to add all the numbers from 0 to 9, but I don't want to add 5. So when we reach 5, we skip it. Then we add 6, 7, 8, 9. So we use continue to skip. Now, if I have a for loop and I say, okay, I want to go from 0 to 9, but if the value reach 6, break, which means I can only add numbers from 0 to 5, because when I reach 6, I break, I stop the loop altogether. So what we mean here is that we can use the break statement to terminate a loop. Then we can use a continue statement to skip a condition in a loop. So that very condition, if it's true, whatever we need to do, I'm not going to do it. So let's see this program. Hopefully we have enough time to get it. So we can see this program now. We want to add some values. We have the variable to have our answer, which is called sum. We initialize it to 0, number also to 0. Now the number will be our counter variable. So we say why the number is less than 20. We are going to increment the number. So number equal to number plus 1. Then after we increment the number, we add the sum. So sum will begin from 0. So sum equal to 0 plus what? Our first value, whatever the number is, we start from 0. So 0 plus 0, 0 plus 1, etc. We keep going. But now we said what? This is what we are learning now. If I remove this, it means I'm going to add all the numbers from what? We start from 0. So from 0 to 19. Because when we reach 20, the loop will be 4. So we have to stop the loop. The loop will stop. So this means we are going to add the numbers from 0 to 90, but no, we want to add the numbers that if the sum reach 100, we don't want to add no more. So we use the break that our sum should be either equal to 100. If the sum is equal or greater than 100 or equal to 100, we want to stop, which means our answer, we don't want to have a sum value more than 100. So the sum value should be at least up to 99. Otherwise, unless we remove this break, then we can add all the sum. And we don't know when. So that's why we are using this statement. If I know that if I add up to 10, it will be 100, it will be less than 100, or at least up to 99, then I don't need this condition. So that's why we're using break here to stop the loop. If the sum reach less than almost 100, let's say 99, we are using the int. Now, if no question here, let's see the other example for continue. If we have it right here, no, they still use a break, but let me see. Yeah, it's almost the same program. Let me see. I think the mistake is from the author of the textbook. Okay, so this is the one we have. Oh, okay, so this is the continue now. So you can see the continue here. We say why the number is less than 20. We increment the number so that the condition here can be false one day. Time will reach it to be false. Then we say that if the number equal to 10 or the number equal to 11, we continue, which means I want to add all the numbers from 0 to 19, excluding 10 or 11, excluding 10 or 11. So we're going to add all the numbers from 0 to 19, but we are not going to add 10. We are not going to add 11 to it. But the previous one, you can see, this means I want to add all the numbers. I don't know. But when the sum reach 99, I want to stop the loop. So again, we use the break to stop a loop, and we use continue again to skip a condition while we are still inside the loop. So again, I think our time is gone, and we're going to end somewhere here if no question. I'll wait for a few seconds if you have any question before we go. So let's look at the classroom. If you know you just came in, again, I'm going to call actually before I call, I don't want student name to be on the recording. So if no question, I'm going to stop the recording, then I'll call if you are absent and you came in late. Okay.
Can you put this
So again,
recording on
question?
Can you put this recording on Canvas?
Yeah, I'm going to put it.
Right.
Yes. Actually, that's why I'm recording it. Okay, so if no question, I'm going to stop this. And then we look, oh, if I end for everybody, know what I'm doing here. I just want to stop the recording, not to end it. Where's the recording? Okay.